It is taken for granted nowadays that healthy soil is alive. The ground we walk on is alive. But this was not the case just 40 years ago when Western agriculture thought of soil more like an inert robot. The soil food web methodology describes the community of organisms living all or part of their lives in the soil. It describes a complex living system in the soil and how it interacts with the environment, plants, and animals. It describes the web of life from large animals all the way down to the most basic microbiological level in soil and water. If you really want to grok the soil food web in an instant, do an image search online for soil food web and see any of the incredible illustrations that exist. Or check out the Shaping Fire Instagram today for one of my favorites. The soil food web is at the very core of regenerative agriculture and not only will inform your cultivation efforts to help your plants thrive, but it will inform humanity in how we may heal our planet before we make it uninhabitable for ourselves. If you want to learn about cannabis health, cultivation, and technique efficiently and with good cheer, I encourage you to subscribe to our newsletter. We'll send you new podcast episodes as they come out, delivered right to your inbox, along with a commentary on a couple of the most important news items from the week and videos too. Don't rely on social media to let you know when a new episode is published. Sign up for the updates to make sure you don't miss an episode. Also, we're giving away very cool prizes to folks who are signed up to receive the newsletter. January's giveaway sponsor is Gas Lamp Seeds. You've heard me talk about them before by their old name, Hembra Genetics. Well, Hembra Genetics is now Gas Lamp Seeds. Gas Lamp will award seed packs to 5 lucky winners who are subscribed to the Shaping Fire newsletter. There's nothing else you need to do to win except receive the newsletter. So go to shapingfire.com to sign up for the newsletter and be entered into this month's and all future newsletter prize drawings. I was a little delayed with getting this episode out, so while this is the January giveaway, we will actually do the drawing when I wake up on February 15th to give folks who are hearing about it today a chance to sign up for the newsletter. I'll let the winners know then. You are listening to Shaping Fire, and I'm your host, Shango Los. My guest today is soil biologist, educator, and activist, Dr. Elaine Ingham. Dr. Ingham uncovered the soil food web nearly 4 decades ago and has been pioneering research about soil food web ever since. Widely recognized as the world's foremost soil biologist, she's passionate about empowering people to bring the soils in their communities back to life. Now, be clear when I say that Dr. Ingham uncovered the soil food web, because what I mean is she invented the soil food web, or rather the soil food web understanding of nature, and then continued to research it and teach it, even though she was getting aggressive pushback from the agriculture industry, which essentially made her an activist too, simply for trying to publicly describe how soil actually functions. Dr. Elaine's soil food web approach has been used to successfully restore the ecological functions of soils on more than 5 million acres of farmland all over the world. Her professional scientific experience is long and impressive, and if you want to know it in detail, check out the Wikipedia page about her. Dr. Elaine has also established the Soil Food Web School to educate the next generation of soil biologists. The courses offered have been designed for people with or without a science background, making them accessible to individuals who wish to learn and to begin a meaningful and impactful career in an area that will help to secure the survival of humans and other species. I have wanted to invite Elaine to be special guest on Shaping Fire for a few years now, but decided to wait until I had enough understanding of soil biology to ask her questions that would be of interest to you, the listener, and would be engaging for Dr. Ingham too. As a Shaping Fire listener, you've learned soil science right alongside me the last 5 years. You're going to love today's episode, and Dr. Ingham says she does too. Today's episode is not an introduction to the soil food web. If this perspective is new to you, when you're done here, I recommend you jump over to YouTube for one of the many videos that explain the basics of the soil food web model. Today's episode is a series of discussion lines that have arisen from me actually using the soil food web insights to grow cannabis and my discussions with other regenerative growers. During the first set, we discussed the use of indigenous microorganisms to optimize plant resilience and the overlap between the soil food web and the water food web and what that means for growing cannabis. In the second set, we talk about sterile growing environments, beneficial insects as both garden defense and food web antagonist, and how to get coco coir pots as biologically active as possible. Finally, we finish the episode in set 3 with a discussion of the timely use of aerated compost teas and compost extracts and bringing the soil food web techniques indoors for cultivation. Welcome to Shaping Fire, Dr. Elaine.
I'm very happy to be here. This is going to be fun.
Yeah, I'm so glad to finally have you on the show. So, many of us aspire to strengthen every level of the soil food web in our garden so, we can most effectively play its melody. And this often includes the use of incubated indigenous microorganisms known by most folks as IMOs. But cannabis plants are not indigenous to many of the regions of the world where we cultivate it. Are there ways to make the cannabis plants feel more at home in the environments where naturally they never establish themselves? Like, how can we make non-indigenous plants that we grow connect more fully with the local biology?
We're actually doing a really good job of doing that already. The damage that we do to our soil when we till it, when we put out these salts, the inorganic fertilizers are all salts, and that's definitely playing havoc with those microorganisms that might have prevented cannabis from being able to grow in their particular system. So we're already doing the things to a great deal that would allow or would select for cannabis. So as human beings change things, we are making a better and better environment for cannabis. And so we're already making things better to grow cannabis because it is a plant that needs somewhere between like a 0.5 ratio of fungi to bacteria, up to maybe 1-to-1 equal biomass of bacteria and fungi. And then there are values that we're looking at. Does cannabis need at least 135 micrograms of bacteria and fungi, or is it actually going to do better if we have a little more bacteria? So the bacteria are up at 400 micrograms per gram, whereas the fungi are at half or even less than that, and depends on the species or the subspecies of cannabis that you're growing as well. So I think we're already doing everything necessary to grow cannabis all over the world.
Your answer is surprising, and if I understand it correctly, disheartening, because what I think you just said is because we are eroding the strength of our soil globally, it has less defense mechanisms and is therefore creating a wider environment for cannabis because we're destroying the soil. Is that about what you said?
That's really basically what I said.
Gosh.
Yes. Yeah.
All right.
Great for cannabis growers, but not so great if you want to be growing grapevines or shrubs or different kinds of, the highly productive grass species, for example.
Yeah, or food that has nutrition and all the other things that we need to survive. Mm-hmm. Gosh, all right. So I'm going to slightly change the question then to tease out something else. So even though we humans, by eroding and degrading the soil, are actually making it more appropriate for cannabis, when we do bring cannabis plants into areas where perhaps the weather is something that they're not used to, or the indigenous microorganisms are not what they're used to, even though there is eroded soil, and so we're getting the pH and the parts per million that might be more appropriate for cannabis growing. Are there other things that we can do to decrease weather and transport shock for plants? Because so often cultivators are moving their plants multiple times from a nursery to a grow out greenhouse and then finally into the ground.
Mm-hmm. And absolutely, I think there would be things we could do to make it easier on the specific plants. In that process of dealing with a root system that's getting bigger and bigger and bigger. what we really want to do is give it depth, because properly grown out in the real world, cannabis usually will broaden those root systems, will be a certain diameter from around around the main stems, but then those roots should grow down. They're looking for water that they have to have in the dry seasons of the year. And so if they've got proper structure built in the soil, if they have the bacteria and fungi present that will build that kind of structure, the protozoa, the nematodes that will help to build that structure, then the roots of your plants will go down quite deep. And, we see cannabis with root systems down at 12 feet, 15 feet, 20 feet, depending, I think, on the cultivars, the type of cannabis that you're growing. So when we're thinking about transferring from something that grew up in the the small containers in the greenhouse, and now we're going to put them into larger containers, it's not diameter of the container that you want to think about. It's the height of the growing the container that you're going to be growing that cannabis in. Mm-hmm. Because we want to mimic, we want to have things be more like those plants are used to out in the real world, and they have a drive to get those root systems deep. I'm sure almost everybody is, when they've pulled up a cannabis plant and they look at the bottom and they see the roots just going in circles against the bottom of the pot, that is not good for the plant. You have typically developed an anaerobic condition in those root systems, trying to escape, trying to get down and deeper into the soil. You've made an anaerobic little cubby area that will grow diseases and pests incredibly well. Not going to grow the right sets of microorganisms for the cannabis. Cannabis root systems, obligately aerobic. You've got to have oxygen in there, or they're going to succumb to a number of different stresses.
Clearly, growing in the earth is best, so that those roots can reach far and participate in whatever's happening in the soil food web at that depth. Plus, get their own water. Is there anything that we can do as growers? Because so many of us grow in containers that might be somewhere between 20, 50, or up to 300 gallon pots, but they still don't go very deep. They usually expand out wider instead of getting deeper, and so. Is there anything that we can do to help the roots from becoming, anaerobic at the bottom? For example, anything like as simple as making sure to use linen pots, which let some air go through. Or is there anything that we can do out of that bad situation?
Yeah, if we get the food web into that soil, such that there's a lot of nutrient cycling, there's a lot of protection, there's a lot of building structure, so water is held right at the top of that interface going down, so the plant is getting all the things it needs from a shallower pot. We could maybe reduce that stress. And so trying some of this out and finding out, okay, how wide does something have to be versus the depth that it's going. And that's just research that hasn't been done. I know a number of labs have said, oh, yeah, we should do that. But I haven't seen any data back. And it's been a while since I've actually been growing any cannabis. Just too many other things happening.
Totally. I like what you said about, we will help the root system out by making sure it's participating as much in the soil food web. And just briefly on the last episode, I spoke with one of your students, Andy Marsh, and she was talking about, biological inoculants, not of particular nutrition, but of residents of the rhizosphere. Do you have, any suggestions for inoculating our soil with actual, living beings instead of just nutrition?
Well, that's really what we're talking about when we're discussing soil biology. It's the organisms it's the living part of that soil that we're concerned about, because it's the living organisms, those things doing their jobs so you don't have to do them, is really what we're trying to do. We want to understand the function of all these different microorganisms in the soil, and most people have a hard time believing that there's that many species of bacteria and species of fungi. And in both cases, bacteria and fungi were up in the millions, hundreds of millions of individual species, and they're different in different ecosystems. So we want to obtain a community of bacteria and of fungi and of protozoa and nematodes. We want them all to be good guys. And I know some people cringe when I don't use technical scientific terms, but I think it makes more sense to say we want the beneficials that will help your plant grow. And where are you going to go out there and find them? And find them for the biome that you're already living in. Someday that cannabis plant is going to be planted outside, and it's going to have to deal with the conditions of a normal summer in whatever part of the world you're in. And so you want to make certain that the maximum protection from the species, subspecies of bacteria and fungi, protozoa and nematodes and microarthropods and earthworms and incatrades, and I could keep going, but I lose most people typically about in there. Wait a minute, I didn't know there were that many different types of, yeah, they are. And you need them all. Your plant needs them all to do the jobs that you otherwise are going to get stuck doing if you don't have your willing organic workers in that soil for your plant. So we want to maximize diversity. How do you do that? We're going to have you go out into the area around where you're living, where you're going to be planting the cannabis for, those cannabis that are going to display the particular flavors or tastes, what all is going to be in that cannabis plant. You're going to want to maximize the diversity. So you go out with your collection bag, and it doesn't have to be real large. It could be a little Ziploc sandwich size or quart size baggie, and you're going to take 2 or 3 pinches of this area right around this fungal mushroom. This looks like it could be really interesting, so let's put some of that in there because that could be really beneficial. Well, let's go over here and take a couple of teaspoonfuls and go over there, and every time you see variation, different plants, different microorganisms, most people don't understand that a mushroom is individual strands of fungal hyphae. The individual strands you cannot see with your eyes, but that mushroom you definitely will be able to see with your eyes. And so you might want to make certain that you know who the good guy mushrooms are and take samples from around their connection with the soil, and leave alone the things, the armillarias, the things that could be pathogens or pests. So a little bit of studying up on what are the good guys and what are the bad guys that you can determine based just on morphology. What do they look like? And so you're going to be out collecting a lot of materials. Now, do you collect those in the springtime or in the summer or in the fall? And the answer to that is yes, because it's diversity, and there'll be different sets of species that are awake and functioning at different times of the year. And you want to get them all inoculated into your compost. And then let those organisms grow up that are beneficials. We keep our compost piles aerobic because that selects for mostly just the beneficial microorganisms. So the disease causers, the problem organisms, they like to be there in the root-bound pot because it's perfect with that low oxygen concentration. If we keep that soil well structured by bacteria and fungi and protozoa and nematodes and everything else, making hallways and passageways and building condominium housing building large hotels, building large structures in the soil so oxygen can move through very rapidly, so water infiltrates and gets held in that soil. You never allow leaching to occur because you need all those nutrients, either in a couple weeks or maybe in another month or maybe next spring. So we want to make sure we're holding on to all of these things by making sure we have a huge diversity of all the organisms that grow in the springtime, all the organisms that grow in the summer. And they're fairly different, what is actually growing and functioning. But they take over functions that somebody else was doing in the soil, but they did the work better at 15 degrees Fahrenheit or 20 degrees Fahrenheit, or, so as you go through changes in temperature and moisture, oxygen concentrations, all of those things, you want to make sure you have the organisms that will be there to do the jobs for you. So making certain that you're inoculating indigenous, local things. It is just laughable to have somebody hand you a jug of bugs and say, these are the best microorganisms we've ever found in the soil. What do you mean by that? Who is regarding those 5 species in there as being the best? According to what set of considerations? Are they best at taking up carbon dioxide? Are they best at taking up nitrate? Are they the best at making ammonium? What does your plant need? Cannabis needs a balance, pretty much an equal balance of ammonium and nitrate. And so we want an equal amount of biomass of bacteria as of fungi. And when we get talking a little bit later, I'll bring up the subject of succession, because that's going to be a big determinant of what you're going to do with different kinds of cannabis to get the product that you want.
I have 2 follow-ups. I'm going to ask them at the same time because I have a feeling that you are likely to weave them together. The first follow-up is we're big fans of having biologically active compost piles here to pull from for all sorts of reasons. But I also know that my brethren in cannabis love to cut corners. And so I can very much imagine cultivators taking the collected inoculant and instead of putting it into their compost pile, instead just putting it right into their containers. And so my first part of the question is there a specific benefit to inoculating the compost pile first, even though the process is going to take longer? Is there a real extra win for having it be in the compost pile first? And
Absolutely.
Then second, after you do the collection, but before you do the inoculation, do you recommend just taking the collected matter and just taking it over to your compost pile and just placing it in there, or do you recommend an oxygen incubation, like with an aerated tea, to kind of build up the population first?
We mostly put the organisms directly into the compost pile, because while we want active organisms, we want to constrain the conditions in that pile. So we're selecting for just the beneficials. So you don't ever want your pile to go anaerobic. The instant you start to smell bad smells coming out of that pile, or, funky kind of, the ammonia smell, the rotten egg kind of smell mixed together, how do you describe that? But by smelling it that something's going anaerobic in there. And that means you have to turn. You need to get oxygen in there. If you're too close, if you haven't gotten up to 131 degrees Fahrenheit for a full 3 days, then, you've got to kind of eke along because you really don't want to turn it until you've gotten that preventative kind of medicine for the bad guys are going to get killed by the heat. We also want to make sure there's no anaerobic conditions. So what you might do there, where you can, this is smelling, it's only day 2, and I've got to wait till day 3 to turn it. Hasn't been hot enough long enough to kill the human pathogens, plant pathogens, yada, yada, yada. what you'll do instead is take like a PVC pipe or a metal rod, not a lot of thickness to the hole maker, and you're going to take that and push it down through your compost pile. Pull it back up, because that's going to leave a hole all the way down to the bottom of your compost pile, bringing oxygen back into the system without turning the whole pile. When you've gotten to over 131 degrees Fahrenheit or 55 degrees Celsius for 3 days, then you turn with the pitchfork and get that all aerated up. And there's a very specific way we take the hot middle and put it on the bottom of the pile when you start to turn. And what was in the cold top part of the pile, it goes into the middle, so that's the part of the pile that's going to have killing the disease-causing organisms for part 2. And then the bottom part of the first pile goes on the top. And so you always turn in the same fashion, so you know everything in your pile has been in the hot middle for more than adequate periods of time. And if you can't turn because of temperature considerations, you get the PVC pipe or the metallic pipe and build yourself some chimneys. How many chimneys? It depends on how fast you're getting hot. And this is where we always have people running into trouble unless they take the foundation classes and learn how to make good compost. We have hands-on classes that you can take, as well as the virtual training that you get in the foundation courses. So you always want to learn how to turn. You want to go through all of the, why do we look at the recipe for the compost? We're selecting for those organisms that are going to best promote the plants that you're growing in that situation. So always we want to, always want to make certain that the compost doesn't have any diseases or pests. And you've got to go through that step, because there's no other way to kill all of those bad guys, especially if you've got manure of any kind. Anything that's been around an animal for a short period of time or a long period of time, there's too many pathogens. You cannot be growing something that, you might be lighting up and licking the plant material. Surprise, it had a disease on it. Not good. So we want to take care of that problem before we ever put it out on our property.
Building compost is one of those things that, my dad always said, it's, learn from your mistakes, but if you can, learn from someone else's mistakes. And, I'm a big proponent of people actually taking formal compost classes, because, a lot of the activity we can't see, a lot of it is not intuitive, and you can destroy your own work in simple ways. And so it really is something to actually take a class in.
Yep. The road to hell is, with my good intentions.
Yeah, paid by good intentions. Yeah. So when I first began studying the soil food web, after hearing you speak, I definitely got the impact of, the model of understanding right away. And I started applying it and then, encouraging it in others. But then my mind was blown away a second time coming across folks talking about the water food web. And it's interesting because in your brain, it's kind of like the same basic model, but these were water-loving creatures instead of soil-loving creatures. And then some biology probably loves both. So I assume it would be a fallacy to treat them separately. So what I'd like to know is, how do you think about the relationship between the water food web and the soil food web, and the how they may overlap?
Because you still want the same nutrient cycling. You're going to have root systems down into the water. And I don't know why people always think that, well, if your roots hit the water, you get to the water table, like your roots can't go through the water. Well, why not? What do we keep pouring on our plants in order to get them to grow? Yeah, it's water. So what's so terribly wrong about water? As long as you keep it aerobic, there is no problem. And the root systems of your plants will go right down through whatever water is present, get down into the sediments, and then the root systems go into the sediments, and the sediments are just like your soil at a slightly higher percent moisture. So you have to select for things that can deal with that high water content, and there will be some species that you only find in, like when you're growing rice, huge component while that field is underwater, you will have quite a bit different sets of microorganisms present. As you dry that surface out, those microorganisms that require more than 50% moisture, more than 75% moisture, they will all go to sleep. They form spores. They will be present next year. So how do we get all the right sets of microorganisms back into the soil in a water system? Well, we're going to make compost where we're going to have it pretty wet and soppy most of the time. So you can do exactly what we do with terrestrial systems. You can be doing with plants that are more aquatic. You just have to recognize the needs of your plant. What does your plant do best? Does it like it with the moisture fairly low, moisture kind of medium, or fairly, we're going into the pond here? And you're going to have to do some of that testing probably yourself, because it's not something that in the world of understanding landscapes, we haven't really paid enough attention to this water factor. How much water is normal? Well, it's normal to be at this level in the springtime, and then it dries down a bit, and then it's completely dry in just before harvest, which makes things harvesting much easier. So, pay attention.
It sounds like it's another argument for being sure to collect, local indigenous microbes too, because if you are collecting from many different locations on your parcel, and you are building them into your compost pile at different times of year, it means that you're collecting them. For example, where I live, it rains for a vast part of the year, but my growing season, we turn to drought, and so if I want my soil to come into the drought season already being healthy, and then be able to make the transition to a drier environment, that seems to suggest that I would want year-round microorganisms collected, so that my soil is, jam-packed full of flexible microorganisms that can play that on-off around the calendar, where these folks go to sleep when these wake up, and then these other ones go to sleep in the other one, and so we have this gentle seasonal back and forth.
Mm-hmm. And it's all part of the biodiversity we have to establish right from the very beginning.
One of my favorite things, and I'm probably going to paraphrase you poorly, so I apologize for that. But one of the things that I found very inspiring when I first heard you speak was you were talking about the beginning of the soil as like this threshold point between the sky and the earth, and it all comes like right down there to where we stand. And it really kind of shifted my perspective for how big these two halves are, if you will. I'd like to focus on an inch and a half of the soil food web. That inch and a half right above the soil. So many cultivators choose to grow tiny, 1 to 3 inch companion plants with like a single leaf or 2 leaves to create a short, dense canopy over the soil surrounding the cannabis plant. We talk about using dichondra repens a lot here on Shaping Fire as an example of that. The multitude of roots and the root exudates make for a rich and dynamic rhizosphere rhizosphere, all those downward pathways of all those little plants, create a place for the water to seep through so that we can avoid becoming hydrophobic. And, all that exudate, conversation is really great too. My question for you is this: what sort of life happens in that little space between the canopy, an inch and a half, 2 or 3 inches above the soil and the soil, that inch and a half of bioregion? There's moisture held in there. Who's living there, and what biological processes are happening in that small area?
And I would really encourage you to start looking at some of your soils, digging down and trying to find out where these different layers are. When you're in an old-growth forest, because you don't really have, especially if it's not a very healthy forest, you don't have anything that's going to mix that organic matter layer down into the soil. And it's very harmful for most of our plants to not have some kind of mixing movement. And that's, again, where the microorganisms are going to come into play, because they're going to be moving that organic matter as it's decomposing and getting into smaller and smaller bits. You're going to have microorganisms taking that away to build structure with. And so it's not the top 1 to 1.5 depth. You want to see that organic material, organic material moving down into the soil. So that O horizon, or the intermediate between the organic layer and the first layer of true soil, where you've got sand, silt, and clay present, as well as the organic matter, you want the root system growing down through all of that. You don't stop. If you're a root, you don't stop there either. So the root systems are going to keep on growing. If your roots are stopping at 1.5 inches or centimeters into the soil, you've got compaction, which is deadly when it comes to growing plants that are going to have all of the genetic characteristics that we want: good flavor, strong stem, resistant to diseases and pests. You've got to have normal soil where those root systems are going to keep growing straight down. They don't usually stop. If they're healthy, they don't stop at 1.5 inches. So the roots themselves will be a part of this contingent of moving materials from that organic matter layer down deeper and deeper into the soil. Water moving along, taking the smaller particles down with it, so that you develop a really good A horizon. Mm-hmm. And of course, if you've got a really good A horizon, then as you go deeper and all the small things stay up there at the surface of the soil, the bigger chunks move down deeper into the soil, B horizon. And then as you get deeper and lower than that mixture, it's C horizon, which most soils people look at as being sterile, which it absolutely is not sterile. How far down do the organisms in your soil go? How far down do we see these bacteria, fungi, protozoa, nematodes, microarthropods, earthworms, incatrioids, everything else? So 12 miles. Oh. That's how deep the soil really is. Now, your roots aren't going to be getting down there, but all these really important factors are going on in all of that 12 miles of soil that you've got below the interface with plants. So if plant roots, how far, if you're looking at a Douglas fir, how far down into the soil can the roots go? As tall as a tree is above the surface of the soil, so below. So if your Douglas fir is 200 feet tall, the root system of the plant is going to be about 200 feet down. So it's a great interface between the atmosphere and what it's doing and what's going on in the soil and the soil below that. So lots of things I could go off on go off on, but yeah, I think that's probably complex enough.
If our focus for this aspect is to make sure that the organic material that is decomposing on the top of the soil is finding its way down into the soil to be moved around by the superhighways. Is this a good case for why we would have a companion plant on top? Many people use the term cover crop, even though that's not exactly accurate for us. But this, if we grow these small plants as companion plants and they create a 1 or a 2 leaf canopy, 2 inches above the soil, it creates this zone where I imagine that there is going to be a lot of biological life because it's there's moisture there and it's protected some from direct sun. And what I imagine is that there are lots of organisms that are processing, the healthy compost that I've put on top, or anything I've collected around the area, anything that we put on top, the way it gets into the soil would be improved if I have this canopy that creates this 2-inch area above the soil but below the canopy where there can be active biology. When you hear that, does that sound like nature, or is that just something that I think sounds great?
You've got it almost right. And probably what you're not considering here again is the compaction. You need to have those understory plants, or grow out, and they may only be an inch tall, 2 inches tall. Depends on what your crop plant is, how tall your cover plants are going to be. The ground cover is another, that's the word I was looking for a minute ago. The ground cover. And you don't want just one species. You don't want just 2, because who's going to survive next spring? We can't tell you what the weather's going to be, what it's going to be like. So we want to maximize diversity right there. Keep some of the things that cause maximum diversity to stay in your system from now until forever, as far as you're concerned. We want to prevent water drops falling from the sky to directly impact on the surface of your soil, because you're compacting all of those airways and passageways when that drop hits the surface of the soil.
Wow.
It's the major compacting problem that we have in agricultural systems. Yeah, it's bad enough driving over your soil with the big machinery, but big machinery can be constrained to just 2 wheel rows. Rainfall, how are you going to get it to fall in just one place? And imagine the damage that would be done if it fell in just one place.
I never considered rain as a compaction action, but it totally makes sense. And now I understand better what you said earlier about the depth of the roots, where these short plants might be nice because they grow into like this blanket that protects it from compaction from the rain. But now I understand better that you're also saying make sure you have a variety of plants that are going to have deeper roots, like radishes or something, so that you've got a variety of root depths and a variety of exudate conversation that's taking place.
Exactly. And really, when you start looking at how is it that having plants growing on that surface, short, low-growing plants, they're continuing to have nutrient cycling going on all of the time. So if your plant ever suffers some harm, the nutrient cycling is still going to be there. They're still going to be hooked up to the below ground system of mycorrhizal fungi, because everything in this orchard, everything in your cannabis plot should be connected below ground. Maybe not some of the kales and the cole and the those early successional plots, the weeds, those plants won't have the mycorrhizal connection. But as soon as you get past that, where we're looking at fungal to bacterial biomass ratio of upwards around 0.5 or greater, they're all mycorrhizal. And so everything's tied together. we want the surface protected by the leaf material, because when that drop of water impacts on a leaf, it pushes that leaf down, and the water gently rolls off that leaf surface and ends up in your soil. So we've completely taken care of that compacting effect, and some of those nutrients are moving with that drop of water into your soil. So there's lots of benefits in lots of ways that you've got this continuous cover. Usually these ground covers wake up and start growing earlier than your crop plant. You know, think about, when do you transplant your cannabis into the ground outside? Well, it's not the day after the soil is no longer frozen, because most of the time none of us pay attention to how cold is the soil. Mm-hmm. It's how nasty is it going to be when I have to be out there doing all of this work. And so it's going to be a month later. And so you think of all that time where those understory plants are getting the soil ready for whatever crop you're going to be putting in. It's a little bit of, you need to understand what your particular crop requires in terms of fungal to bacterial biomass ratio. You need to have that time to build the fungal biomass if you're lacking in fungi, or build the protozoan populations and the good guy nematodes, so that you've got maximum nutrient cycling. All of the things are being held and stored and moved and built just exactly the way they should. So we want nice cover, not just here and there. We want the best places where I'm seeing the best coverage is where they have 20 different species of seeds that have been spread. And you can see where this summer up comes these 5 species of ground cover, but really you don't see much of the other ones. But next year, it's like none of the 5 that were really important last year, they're not even, peeping their heads above, because things just are not right for them. And so you want to have something that's going to go, yay, this is perfect for me. And so you'll get 5 or 6 different species showing their heads, and then there's always those years where everything grows, and it's spectacular. When you look in your, in your garden is really what it looks like, because you've got the rows of the plant you're trying to grow for profit, and you've got all of these understory plants that are just peeking through the blades of and showing their heads, so that the flowers are beautiful. Mm. So lots of things to sit back and understand, and we're still trying to figure out a lot of these things. It's always interesting to try to figure out, where does all this nitrogen come from? We have a bumper crop amount of nitrogen in our soil, but if you go and try to analyze, soluble nitrogen, total nitrogen, exchangeable nitrogen, there's a missing part of the nitrogen cycle that we're not paying any attention to at all. And so, people always do calculations of, well, you couldn't possibly keep these, 440,000 individual plants, you couldn't possibly keep them alive and happy with really high levels of nitrogen in them if you don't use inorganic fertilizer. And yet, all of our plants have much higher levels of nitrogen than the chemically grown plants. So, which one's going to give you better flavor? Which one is going to give you more nutrition? Which ones are going to taste better? So there's some of this work that we've still got to, Mother Nature has not yet revealed all to us. We've got some more work to do.
What a great time to be a young scientist coming up into the system where, you've broken the idea of, the soil food web, and that Even though it seems obvious now, that the soil is alive, but now we also have got the analytical technologies to take measurements and see what we're working with. It's a great time to be coming into thinking about regenerative growing. So
Indeed.
we're going to take a short break and be right back. You're listening to Shaping Fire, and my guest today is Dr. Elaine Ingham. Without these advertisers, Shaping Fire wouldn't happen. So please support them and let them know you heard them on Shaping Fire. One of the challenges with buying autoflower seeds is that often you'll have as many different phenos as you will have seeds in a pack. That can be fun, sure, but so many varieties in one pack is a sign of an immature seed line that hasn't been worked enough. I prefer my autoflowers to be worked enough that each pheno in the pack really captures the aspects that the breeder was intending. This is why I recommend Gnome Automatics to my friends and listeners who grow automatic flowering cannabis seeds. Gnome Automatic seeds are not just crossed and released. They are painstakingly sifted again and again, tested in a wide range of conditions, and taken to a level of maturity that each plant will be recognizable by its traits. Traits that were hard-earned so that you can have your best growth cycle ever. Over the last 10 years, Gnome Automatics founder Dan Jimmy has become a trusted breeder, and he continues to pour his passion of breeding cannabis into every variety he releases for you to grow. Check out the Gnome Automatics Instagram at gnome_automatics to see the impressive plants folks are growing. You can score Gnome Automatic seeds in feminized or regular at your favorite seed provider listed in the vendors section of their website. Commercial cannabis farms across the country love growing Gnome Automatics because of their consistency from seed to seed, short grow times, THC percentages, and colorful bag appeal. Farms interested in bulk seeds of more than 1,000 should reach out through gnomeautomatics.com. While on the website, be sure to check out the Gnome Automatics shirts and other merch section too. If you want reliable seeds, hand-built from effort, expert selection, and experience, choose Gnome Automatics. Online cannabis seed distributors often seem to be all the same. But Multiverse Beans constantly works to provide you with cannabis seeds and a buying experience that you won't find elsewhere. Multiverse Beans works directly with the breeders to secure as many packs of your favorites as possible so that they have your favorite beans long after others have sold out. Some shops simply buy breeder minimums, but I get messages all the time from breeders saying some version of Multiverse asked to buy my entire run. At multiversebeans.com, you can find rare cannabis seeds from Night Owl Seeds, including the Dark Owl sublabel, Mephisto Genetics, Square One Genetics, Robin Hood Seeds, and Ethos, and so many others. Multiverse also initiates projects with breeders to secure exclusive packs that you simply won't find elsewhere. Multiverse founder Paul Lal sees himself not only as a curator of the best cannabis seeds available, but also as a collaborator with breeders, trying to bring novel crosses to the market that his customers are asking for. Multiverse Beans also creates exclusive stickers for their popular seed varieties that are available free only when you order those seeds from Multiverse. Check out their stickers like the badass recent slap for Mothman by Gnome Automatics on Instagram at Multiverse Beans. And finally, the freebies. As you'd expect, Paul sends quality freebies with every order. And when you spend at least $150, Multiverse allows you to choose your freebies from their special selections. You can get a 10% discount off regularly priced items when you use the discount code SHAPINGFIRE, all one word, at checkout. Sign up for their mailing list to be eligible for their monthly seed giveaway worth $250. So go to multiversebeans.com now for a buying experience you won't get anywhere else. As cannabis regulations become more demanding and consumers become more educated, it is increasingly important to avoid the use of chemical pesticides when cultivating cannabis. Beneficial insects have been used for decades by the greenhouse vegetable and ornamental plant industry, and today many cannabis cultivators are moving from sprays and chemicals to beneficial insects. Copert has the beneficial insects, mites and nematodes, microbials, sticky cards, and air distribution units you need to partner with nature to defend your garden. Whether you manage acres of canopy or have a simple grow tent in your home, Copert is ready to help answer your questions and help you transition away from chemical sprays towards clean and natural solutions. Since 1967, Copert has assisted growers in identifying pests and devising reliable solutions while providing healthy insects and mites that will protect your yield. Since the 1990s, Copert has been a leader in cannabis pest and disease control worldwide and have highly trained consultants to assist you in Canada and the United States from coast to coast. With their global network of grower support, Copert can help. Visit Copert.com, choose your country, and get detailed information. That's Copert, Koppert.com. For the most up-to-date cannabis-related biological control information, you can also check their Instagram at Copert Canada. You know getting away from pesticides is good for health and good for business, and Copert is ready to help. Visit Koppert.com today. Welcome back. You are listening to Shaping Fire. I'm your host, Shango Los, and my guest today is Dr. Elaine Ingham. So before the break, we were talking a lot about the importance of encouraging and supporting the soil food web and making sure all of the different plants in your garden are talking with each other, because indeed we are looking to support a web of communication and transference of nutrition and things like that. So, Dr. Elaine, many cultivators aspire to the soil food web ideals, but they still get hung up on keeping sterile growing environments, like even outside. Instead of focusing on biology and balance, they intend instead for like ideals like zero pest present, like there's not a single pest in my garden. How do you teach the mindset of the soil food web so that your students understand this softer idea of biological inclusion in balance instead of the absolutist ideals of zero tolerance for anybody who isn't on my team?
Yeah, it's because it's what we were all taught when we were in grade school, middle school, and so on. Certainly in any microbiology class, what's the most dangerous thing you're going to encounter today? The door handle on the room, because everybody touches it going in and out. And not really. It's not like that's a special place for disease-causing organisms to grow. You're just inoculating a lot of really interesting things on that door handle, but you're also inoculating all of the beneficials. So there's a balance there that you've got to think. If you've got people with good, decent, they've picked up their apple every day, or they've picked up some really good soil, smelled it, they're working in their compost pile, you don't have to worry about the doorknob anymore. Every morning, go out there and wipe all of your doorknobs with a really good handful of compost that has got all of the really beneficial organisms in it. One of the mechanisms for why this is important is that if you've got a sterile system, there's nothing to stop the disease-causing organisms if, perchance, they get inoculated. And so runs through your greenhouse, all of the containers, all of the benches, below the benches, all the little spiders and all the cute little buzzy little flies that drive us all crazy. Where did all of these aphids come from? Where did these white flies come from? Well, it's probably came because you're being too sterile about things. You're not letting there be those things that would wipe out those diseases and pests before they ever got to a high enough concentration that it would start bothering us as human beings. So whenever we're looking to get rid of a disease-causing organism, especially in a greenhouse, is go in and look and see where might the spores be hanging out. And they're going to have a specific part of the greenhouse, or if you're outside, specific part of the soil, typically low oxygen, lots of dead bodies of things and things for them to, chow down on. So those eggs or spores, when they hatch, have all the food they need right around them so they can very quickly move into the next stage of their life where those larval stages are moving off someplace else, and they need the unclean ecosystems in order to thrive and have each one of those larvae make it through to adulthood. And then, the mom and dad, they're flying around. They're every place they touch is going to be a mass of these disease-causing organisms going out on the surfaces of the above-ground parts of your plants. On the crown of your plants, quite often, I'm sure some of you have noticed that some of the larvae hang out right there at the crown of the plant. That's their favorite place, and they're slowly munching through and killing parts of the root system, which now are going to, of course, be anaerobic and chock full of diseases. So sterility is not a good idea when we're trying to prevent, exactly why we were spraying horrible toxic chemicals all through the greenhouse. So we want to have all of these beneficial organisms in there so that when that disease-causing organism is accidentally brought into your greenhouse and somebody leaves the handprint, we want to have those beneficial organisms that look at those disease-causing organisms and go, "Wee-haw, somebody brought lunch." And they chow down and take them all out. There's a direct conflict in many cases with those kinds of organisms, and the beneficials regard the disease causers as just a source of food. You want those kinds of beneficial organisms in your system. So sterile, not a good idea, because you can't keep human beings sterile. And they're probably the biggest problem in spreading diseases throughout a greenhouse and in places that you'd never think about. Like when people are standing at the table and they're transplanting this plant from A to B, and they take all the dead leaf material off, they maybe see some dead roots and they pull that off. What are they doing with that plant material? They drop it on the floor next to them, right? And now you've set up a perfect environment for all of the whiteflies and the microarthropods, the little tiny flying critters. Perfect place for them to lay their eggs and for the larvae to hatch out and go through that whole stage right there in the gravel under your feet. And people don't think about they've got to clean that too. So what's the best way of cleaning that floor material? Apply some compost tea. Apply some compost extract that's got the organisms that are going to take care of all of those disease causers. Yeah, you have to keep it aerobic enough, so don't overwater. But that's certainly when you look at what triggers the plant's immune system, its resistance to diseases and pests, it's those microorganisms that will trigger, they'll send out to the plant the information that there's something bad happening here. The hordes of, I don't know, what should we call them, purple devils are coming at us. They need help from the plant, and the plant needs to contribute something to the upkeep of those bacteria, fungi, protozoa, and nematodes that will attack and consume the diseases and the pests.
I can almost hear the greenhouse managers listening to this being aghast, because their normal mindset is probably to spray or clean their floors with either some kind of chemical sterilizer or a 10-to-1 bleach, depending on the variety of floor they have. And now instead, we're talking about no, spray them with compost tea because we want the entire environment to be tied together biologically, so that it's prepared for any invaders. And it makes total sense when you say it, but it's also heresy from the way things have been done in the past.
Yeah, because we didn't understand.
You're no stranger to heresy, though, Elaine.
What have I done all my life? because I'm mostly interested in the truth, and I want to understand why things work. And when we've had systems that depend on pulling the wool over people's faces, and because that's what the chemical industry is, they've been convincing us to put out terribly toxic things to kill particular sets of microorganisms who then just develop resistance to those chemical applications. So now how are you going to deal with these problems? The only way is biologically. We've got to get the beneficials back out there. We've got to keep it aerobic. Yep, so that's a biggie. We want to make certain that we've got critters that eat those organisms, and we want those things that will inhibit, definitely with toxic chemicals, but it doesn't leave the area around the bacterium or around the roots or the hyphae of the plants. They don't just mindlessly go out and apply massive amounts of toxic chemicals far beyond what you actually need. So let's give these organisms a chance to show you what they can do, where you will become accustomed. Hopefully all of our children will read stories about this time in life, in the history of man, and go, how could these people have been so blind? Yeah, it's the power of the written word, isn't it?
It's amazing how much of that is, sure, we need to learn best practices for using nature to support nature instead of chemicals to keep nature at bay. But like outside of the best practices, so much of it is just trust too, because I was brought up to trust chemicals and pharmaceuticals for that matter. And as we realized that was a, philosophy that over time was bunk, now we need to kind of like untrain ourselves back towards regenerative, which for the most part is what we try to do here. I've got another question about the pest populations that's kind of a corollary to this. More and more folks in cannabis are learning to effectively use beneficial insects and trust them more, just like we were talking about. When I think about beneficial insects through the lens of the soil food web, I kind of imagine that dumping thousands of beneficial predators of any variety into a cultivation area might throw off the balance of the local soil food web. Certainly, target pest populations will be reduced, right? Whatever it is they eat. But are there any other potential soil food impacts that we should be aware of when using beneficial insects? Because we are super packing a particular niche of the soil food web with suddenly a lot of participants. And I like the idea that they're just going to eat the target pests and then eventually go off to find new food sources. But I don't actually know that to be true.
And it's essentially true, but it's like when you put a huge amount of a predator into the system, it's going to go looking for prey, and it will drop the species. And what if those things that just got eaten by the beneficial insects, what if they were what prevents some other disease from attacking the root system of your plant? And so you homed right in on exactly what the problem is. It's a density problem. You've got to spread those beneficial insects out throughout your whole bed. You can't be applying them, everything goes into the soil down here, and we assume they're going to spread all the way down the end of your bed or your agricultural field. You want to be putting a few in every places you're going down the line, just a few, because it takes a lot of microorganisms, a lot of the smaller critters, to satisfy the hunger of the predator that you just dropped into the system. And they were already competing with each other in whatever container you were keeping them, and now you've let them loose and they just go crazy and knock the beneficial prey group down to almost nothing. So now you're looking for potential diseases. we need to, and so here's something that we haven't quite gotten around to, we need to have our microscope, look at it and go, here's the problem organism coming on. And so I need more of, these bacteria, I need more of these fungi if I'm going to put in more of these beneficial insects. They're going to be eating my bacteria and fungi, and so I better make certain that my bacteria and fungi get a little bit of extra food so that they can multiply and maintain balance. Either that or you're going to have some real shifts and swings and lots of good nutrient availability in the soil, and all of a sudden, because you put on the good guys for keeping the disease-causing bacteria in line, you're also going to lose your good bacteria, and now there's not enough nitrogen, phosphorus, sulfur, magnesium, calcium available to your plant around that root system. So if we would only do it one root at a time, it might work. But we're doing this to the whole system. So I really do like to put these organisms into the compost itself and let that predator-prey balance itself out. And so when I put the compost out there, it's already with adequate amounts of bacteria or fungi or protozoa or nematodes or whatever, as compared to the predatory organism that you put in there to shut down the disease-causing or the pest microarthropods out there.
This idea of having over-dense beneficial insects is the first time that I've ever wrapped my head around the idea of actually listening to application rates, because I really had never thought about, using so many that they would go and start to be opportunists on other necessary food sources that are not the target pest. And, it's true, when I reach out to my, my covert rep, and, I don't have a big garden, but I figure out what I need with them. And then I get my, my bugs, and I'm like, okay, the application rate says this much. And then I apply it to my, pretty small garden, and then I look and there's all this left in the bottle, and I'll cop to this. I'm like, I've got extra. They'll be more safe if I add the rest. And like I've done that every year, and now I'm realizing that it's actually working against me. And really, what I should do is hand those beneficial insects off to a friend for their garden. Yeah, somebody else who can really use them and will see that benefit. Because you've used them before, you probably have a certain amount of the beneficials present, because they leave eggs, they leave dormant stages, and they'll be up and moving, doing their thing. You probably don't have to add as much in the second year. So, give it to friends, give it to people, and say, tell me how it works out for you. And then pretty soon you have another client. I want to hit on the pathogen topic. Again, you were talking about, when people drop necrotic leaves on the floor of the, anywhere, greenhouse or outside in their garden or whatever. It's incredibly common for cannabis cultivators to defoliate their plants to open up airflow towards the inside, or to remove yellowing leaves and place them on the surface of the pot. And the kind of bro science idea is to return the nutrients in the leaf back to the plant. It'll be good for the plant because I'm just returning nutrition. But on Shaping Fire episode 88, plant pathologist Cora McGee suggested that all those leaves should be removed from the cultivation area totally to prevent the spread of pathogens. What are your thoughts on this very common practice of cultivators to put even the healthy leaves that they take off onto the top of the pot instead of, removing them from the grow area to the compost or something?
Yep. Well, if you have no biology in your dirt, then you have to do what she said, because there's those leaves, brown, diseased, happy, good leaf material, the diseases are going to take those over and serve to increase the disease. If you have no decent biology in that soil, if you're trying to grow plants in dirt, it's not going to work very well. But if you are using a biological approach and you've got these really good organisms in your soil, then the way to tell if it's working, that you drop those infected leaves on the surface of your soil, you should see by the next day that things are happening. These leaves are getting eaten. They're being decomposed. They're being turned into soil as you watch. So how long is it going to take for a small cannabis leaf to decompose? A couple days. How about a bigger one? What if we've got a real big, well, it would help if you shredded that up a little bit and put it on the surface of the soil, because in a couple days, those materials would be gone as well. You might still see the skeleton of the major veins for a couple more days than you see the green plant material. But it should all decompose. If it doesn't decompose, then Mother Nature is trying to tell you that you don't have all of the biology that you need in here. Please go get your microscope. Go take a look at what the biology is in this area. Why aren't they here? Because they should be. If you used good compost teas, you should have all of those organisms in the soil, and that decomposition should be overnight. So if it takes too long a time, you probably want to try to figure out who killed your microorganisms in this part of the pile or in this part of your growing system or greenhouse. And quite often we discover the places where your neighbor sprayed something, and that spray blew into your operation. And so right here, we're not seeing any decomposition because we got glyphosate in here, and that killed your organisms. Well, it's not going to take that much trouble for you to go get a little bit of your compost and sprinkle it over that area and make sure that the decomposition comes along right away, and then you're good to go. So we have very simple solutions to some of these quite complex problems that other people have.
Mm-hmm. It's interesting to tease out the differences in perspectives of scientists, because I can see very clearly now that, Cora offered that opinion because she works in a fusarium laboratory greenhouse using sterile soil because they're studying fusarium. And so for her, she doesn't have the strength in her growing system of a very active living soil, because that would get in the way of their measuring things, right? And ensuring it. So it's always interesting to be able to tease that out, because so many people in cannabis, they'll argue, well, this specialist thinks this and this specialist thinks that, and one of them has to be wrong. And I'm always like, you really you've only learned that kind of like at a t-shirt quote level, like you really need to understand what's behind what they're thinking before you get all evangelist about it, or especially angry about it.
Yeah. And ready to chew somebody up one side and down the other, which is not a fun thing to do. If they just took a step back, viewed the system and realized what's actually going on, we aren't going against the principles of chemical agriculture. We're just paying attention to what Mother Nature has already put in place. And Mother Nature has been working in these systems, been working on this planet ever since rooted plants arrived on the planet, which was 1 billion years ago. Mother Nature has had 1 billion years to figure out these interactions to keep all of these wonderful plants alive and functioning. If she didn't work, then we would be in serious trouble. We wouldn't have these plants. So we've got to learn the messages from nature. We haven't figured them all out yet. Please come work in the lab with us for a while and discover all of these things, and then you too can get your name in lights.
So, we're big fans of living soil. I mean, you and I both personally, but also like Shaping Fire, the program. We talk primarily about living soil. We don't talk a whole lot about hydro unless it's, a special water food web kind of hydro setup. But using a blend of coco coir and peat is wildly popular in cannabis cultivation at the moment, especially like bagged coco coir and peat with often with preloaded with nutrients, but it isn't soil, right? And the biology of these pots seems like it would be significantly lacking in soil food web biology that makes plant living in soil thrive, right? Because they don't have the sand, silt, and clay and organic material in them. What are your thoughts? Like, how do you teach this idea of the threshold between using soil, which has got, sand, silt, clay, organic material, versus using coir and peat with nutrients, because they both grow plants and people are very satisfied with their cocoa plants. But I feel like they're leaving some taste and pest resistance and resilience and health like on the table because they're choosing like a half step and not going all the way to living soil. What are your thoughts on these cocoa peat mixes?
Cocoa and peat probably need to be sterile. This is one of those situations where it probably, because you've got the material in a plastic bag sealed, and if there's any active organisms in there, they're going to start growing on all that great organic material in there, and your bag is going to puff up and explode. So they have to have used some kind of toxic material in order to kill off the organisms in that peat and coconut coir.
Could it just be like heat or pressure, or does it?
Could be. It depends on exactly what they're set up to do. So,
but one way or another, they're denaturing it.
Right. Yeah. They're exiting that from the system. They're making certain that nothing's growing in there. So now when you add your organisms, say in a good compost, you're going to see some initial lag before the organisms really get going. And often, if the concentration of that toxic material was really high, you won't see any microbial growth, and therefore you're not getting what you put the peat and coconut coir in there to do, which is provide a food resource for the microorganisms that you want to help your plant. When we get into an understanding of what's the difference between soil and dirt is just the mineral materials. So the sand, the silt, the clays are produced by weathering, and that used to be the biggest thing that could start breaking down the boulders and the parent material and the rocks and etc. into sand, silt, and clay. But as soon as microorganisms came along, it's the microorganisms that do that decomposition of the rocks, pebbles, everything else. And that's what's producing sand, silt, and clay. So very specialized niche. You don't need many of them because they're not really going to be helping your plants along, but Mother Nature needs to have them out there so we can go ahead and get those nutrients. But so I've defined dirt, just the mineral component. When you're talking about soil, you have to add, and this is according to the work of Hans Jenny, one of the fathers of soil science. He defined soil very clearly as being the mineral component, the sand, the silt, the clay. But you also have to have organic matter in order to feed your microorganisms. And then you have to have the beneficial microorganisms, the bacteria, fungi, protozoa, and nematodes at the very least. And then more microarthropods, macroarthropods, spiders, and all those things also play into a really good, well-rounded soil. So that's the difference between those two things. The mix that you talked about is just food, organic matter. That's all that's going in, especially since they had to, destroy the biology on that organic material in order for it to sit happily on the shelf in the greenhouse, in the store, wherever they're storing it. So we want to make certain that we get that planting material out and mix it with our compost, making sure that the compost isn't killed by the toxic chemicals that were used to kill everything in that organic matter. Okay.
So I'm gonna take it one more step and put a little sharper edge on it. And the reason I'm doing this is because so many newer growers ask me about coco peat mixes, and I don't want to repeat inaccurate or incomplete information. So I'm going to take it one more step. Let's say that that the person is using a coco peat mix that has been denatured or sterilized with heat or pressure, and so we're not talking about residual toxins. And then the folks bring it home and they fill their containers with the coco peat blend, and then because they want to capture some active biological activity, they'll pour compost teas in there, and many people have the idea, it's like, okay, now my preferred substrate that I like to use now has microbe life in it because I just poured my tea in there. And I've always resisted this idea after Jeff Lowenfels kind of said it real easy. He says, it's not living soil if worms aren't living in there. and that generally, it doesn't apply to, or that's not going to happen in this kind of like coco peat mix I'm talking about. So what are your thoughts on starting with a non-toxic but sterile coco peat blend and then adding compost teas? Does that get you there?
It certainly should, especially if that compost that you use to make the extract and then the tea, if it has the spores as well as any of the dormant stages washed off that leaf material, that compost material, and into the water that you're now going to inoculate on the peat moss and coir. It's always a question of how much. You don't want to overdo because that's a really strong food resource, and you might have such a rapid growth of microorganisms in your beds that now that
since
it goes
you started
anaerobic.
From zero, yeah.
Because you now let this goodly amount, maybe too much. And how do you determine what's too little and what's too much? And we often encourage our students to do a little bit of testing in small containers. So take a handful of your compost, take a handful of the peat and coir mixture, and mix it all up. Now put some of your compost tea in there at the concentration that's the same as outside, and watch and see what's happening. And if you come by the next morning and you go, what is wrong with there's a smell in here, where's that coming from? It smells like someone vomited. And you realize that that's your little container of coir and etc. You put in too much biology. That's too much food for them. So, crank down the amount of compost that you're putting in with all those great organisms. Reduce it by half and see if you don't get a better effect. You don't really want to be experimenting with something where you just put your valuable plants into. And, the next morning it's, oh, surprise, how dead is that plant going to be? So that's the care that I would want to have people take. Get that microscope out, take a look at the biology that's present. As soon as you mixed everything together, and then 24 hours later, take another look and see that everything has just gone gangbusters, and it's floor to ceiling bacteria squished into small places. Not what we want. That's too rich for your plant. So back off.
So it sounds like if I were to kind of tie this all together into a quickie best practice, it would be if you prefer to use coco and peat, and make sure that they are denaturing from something non-toxic like pressure or heat. And then once you get it to your house and you want to add biology to it, go ahead and use your compost teas, but start slow and low so that you don't push it too far too fast. And I would think that I would want to encourage people to also use a variety of teas and like worm casting extracts and things like that. So you're continuing to add variety to the pot in slow amounts as you go. And, it won't ever become living soil, but if you've chosen coco, this is going to be your best way to also have an active biology.
Yeah, and for me, it's still a compost, because the coir and the peat moss, those are just foods for your microorganisms. So you're going to have to replenish that food, or maybe, as you're taking a little bit of compost, you have a little bit left over, spread it out on this field so you get a little bit of the sand silt clay mixed in. Yeah.
That's interesting. I never really considered coir a food, and as it degrades, I can see how it would be. I've always kind of thought of it as like akin to styrofoam.
Yeah, nope, it's definitely a carbon source. Mm-hmm. Yep, and your fungi need that. Bacteria don't like it much, because bacteria have a carbon and nitrogen ratio typically down around 10 carbons for every 1 nitrogen, which means all bacteria are desperately in search of nitrogen. And they get all the carbon they could possibly ever use, and they blow it off as CO2. So they are not the organisms we want in our soils if we're trying to sequester carbon. You want to get the fungi growing, because fungi have a C to N ratio of up around 100 to 1. And so the fungi will take all that extra carbon and put it inside its empty fungal tubes, the empty hyphae. And that prevents microarthropods from being able to eat the fungus. So it's a really good way to put things away in a very safe place for a very long period of time. So if you're ever thinking of carbon sequestration, keep that in mind.
Right on. I'm really grateful that you went down that path with me, because I'm much happier, because, historically my coco friends, I kind of make it a habit to ask them hard questions about the biology. And instead of being a jerk like that, I can go to them like, oh, do you know Dr. Elaine's best practices for this? Here, let me support you in your chosen way. And I think that's a much better way to interact with my friends.
Yeah, I just, why are they taking the peat moss? There's so many other good sources of food for the microorganisms right around you, in your natural biome, in the habitat you're in. Why buy something like peat moss that's destroying an ecosystem someplace and using that as food for your microorganisms? Why not, there's lots of other places where you could get waste organic matter, and as long as you keep in some eye on how much banana peel and how much oats and how much of, what are your kids eating, and you're putting in the garbage, dry it out every night. There are dryers that you can buy that are very inexpensive. And then you just, when you finish drying it down, you just crunch everything up and put it in a bag in the refrigerator. And so you can make your own peat moss.
So, while peat certainly has a use as a source, most of the time I'm hearing people say that they like the peat in the mix because it retains water and it helps kind of like balance the water that's in a container. Is there something else that you prefer to peat to help kind of stretch out a watering and kind of help regulate how wet the pot is, or rather that will sustain the watering a little longer in a balanced way?
You want to get the particles in the whatever you're, like my example of the food, waste food in your kitchen, and you dry it down and you grind it up, and now you take it out of wherever you're storing it, because if it's completely dry, you don't have to worry about it. And take that out now, and how much water will that dried material be able to hold? And usually it's quite close to peat moss. So I kind of think of those kinds of materials, because it's a diversity. You've got some potato, you've got some banana, you've got, what else did your kid not eat? Broccoli, cauliflower. And you dry them down, and now how much water will it take to wet that back up? And I think you'd see it was very close to the peat moss.
Thank you for that. I've only ever thought about those scraps as a food source and not as a,
water holding capacity.
Hydration. Yeah, totally. So, all right. So we're going to go ahead and take our second short break and be right back. You are listening to Shaping Fire, and my guest today is Dr. Elaine Ingham. One of the reasons why no-till cannabis growing is so valued by farmers is because the mycelium networks in the soil remain established from year to year. And we know these fungal networks are essential because they are the nutrient superhighways that extend far and wide in the substrate to feed your plants. The trouble with growing in new living soils or blended coco substrates is that it takes most of the plant's life just to create these mycelium highways. Dynamyco endomycorrhizal fungi inoculant reduces that time and gets your plant eating a wider array of nutrients faster. And it's 3 times the concentration of the other popular brand in the U.S. at 900 propagules per gram of 2 fungal species selected specifically for cannabis cultivation. Dynamyco is the result of 30 years of research and trials at the Volcani Agriculture Research Institute in Israel. It has also been vigorously trialed by cannabis and food growers across the U.S. Dynamyco is now available at grow shops and on Amazon in the United States. I love using Dynamyco to both speed up the growth of the mycelium networks in the soil, but also as a biostimulant to make clone cuttings more virile. You can see side-by-sides showing the comparative growth on their Instagram at Dynamyco. If you demand reliable growing results and appreciate the importance of an active root zone in creating a thriving plant, I encourage you to check out dynamyco.com and use the store locator to find out where you can get yours. That's dynomyco.com. Shaping Fire listeners can get 10% off any size of Dynamyco on Amazon or dynamyco.com by using the discount code SHAPINGFIRE, one word, no caps. Whether you are starting with new beds or pots, or if you want to add some zing to tired soil, choose Dynamyco to maximize your plant's potential. Dynamyco endomycorrhizal inoculant. There are so many seed banks nowadays that you really have options in who to choose. Not only that, if you pick the wrong seed bank, you could be in for a really sketchy ride. And that's only one of the reasons I recommend gas lamp seeds to my friends and listeners who are looking for a seed bank. You probably already know gas lamp seeds as Hembra Genetics. Hembra recently changed their name to Gas Lamp Seeds. Gas Lamp Seeds is not just another seed bank. Gas Lamp is a female-operated boutique cannabis genetics provider that only sells thoughtfully curated seeds from the top names in cannabis breeding. With over 60 breeders and over 1,000 strains to choose from, you will certainly find something you'll love. Gas Lamp Seeds has something for everyone, with over 650 feminized strains, 300 regular varieties, and over 200 autoflowers to choose from. Names you know you can trust, like Compound Genetics, Humboldt Seed Company, Night Owl, In-House, Fast Buds, Gnome Automatics, and Ethos. And we both know that there are other seed banks who will take your money but have no customer service. I invited Gas Lamp to advertise on Shaping Fire after hearing so many good stories about them from my friends. They have A-plus customer service with lightning-fast response times. In most cases, Helene and Caitlin will get your order out the same day you place it. Most seed banks are simply not this organized or interested in getting your seeds to you so fast. But Gas Lamp Seeds cares. You even get free seeds with every order. Helene and Caitlin get it. They have been in the cannabis growing scene for over a decade. Want some extra freebies? Use the code SHAPINGFIRE, all one word, at checkout, and they will give you an additional set of gas lamp provided freebies. That's an extra $30 in free seeds. Buy seeds from good folks who will send you great seeds reliably every time. Visit gaslampseeds.com today. That's Gaslamp Seeds. For years, organic cultivators have been looking for a peat moss replacement. Peat moss has long been the go-to soil amendment for water retention and container growing, but organic growers are recognizing now that peat moss is an unsustainable resource, and the mining of peat bogs destroys wetland habitats and releases sequestered carbon. But peat moss works so well that many have continued to use it. Now there is finally a revolutionary replacement for peat moss that provides better benefits while being a sustainable choice. Pit moss sounds and acts like peat moss, but instead of being mined from fragile ecosystems, is actually made from upcycled organic paper and cardboard headed for landfills. Pit moss is excellent at retaining water in your substrate and creating air pockets and tiny living environments for microbes. Pit moss instantly increases aeration, nutrient absorption, and water conservation too. Carefully and locally sourced, pit moss is the result of decades-long research into the use of recycled paper fibers. Pit moss is lightweight and easy to use, and pit moss is inert, so it won't change your pH. Available in a range of preparations, including a nutrient-enhanced blend and an organic soil conditioner with no added nutrients. Pit moss is also available as an animal bedding for horses, chickens, and small animals. You can save 15% with the discount code SHAPINGFIRE, one word, no caps, when shopping on pitmoss.com. So go to pitmoss.com now to learn more. That's PITTMOSS.com. Growing healthier, stronger, more sustainable plants. Pit moss. Welcome back. You are listening to Shaping Fire. I'm your host, Shango Los, and my guest today is Dr. Elaine Ingham. So, Dr. Elaine, in regenerative farming, we do our best to mimic nature itself, to support it, and, use nature to repair itself. Does that make a case for cultivators to emphasize compost extracts over aerated compost teas? Because, burgeoning incubated populations of oxygen-loving microbes are pretty unlikely to occur naturally in the soil, while compost extracts really more effectively biomimic what happens in nature by seeping into plant material and then seeping through it as we find in nature. So how should we wrap our heads around that?
It's one of these cases of it depends. You have to take a step back and look at what you want as the outcome of applying these different materials. So, for example, with a compost, you're going to put it down someplace that needs the organic matter as well as the organisms replenished in that soil. And so typically right down the furrow, or right around the trees in a orchard, or something, shrubs or blueberries, whatever. When we're looking at compost tea, that's really the organisms as they typically exist in our close, the closest we ever come to making soil. Those organisms we want to extract at the concentration that you need to put into your system to get the biology back up to where it belongs. So when we're going through succession, and we're trying to understand that early in succession it's strictly bacterial, midway through succession it's 50-50. Fungi, bacteria. When it's in an old growth forest, it's 100 to 1,000 times more fungi than bacteria in the system. And so, understanding that we are going to extract the compost and apply it as that amendment. Everybody's going to be asleep normally that is supposed to be asleep at that time. Anything that's supposed to be happening now, that's already happening in the compost. So when you do the extraction, these organisms go out, hopefully more or less in the balances that we want to see. So we'll take a look using our microscopes to determine if what I'm putting on is strictly bacterial, and that's going to help those early successional systems that we probably don't want, because early successional systems are going to be mostly weeds and things that aren't crops. They're not really anything that farmers want to see. If we improve that fungal component, then we're going to be putting on an equal biomass of fungi and bacteria, and we're selecting for the more productive plants in the system, grasses and vegetables, those kinds of plants. As we go over the edge into a fungal-dominated system, and now we're promoting the growth of shrubs and trees, the higher in that successional process, up into the old growth system, we're going to be just pushing fungi like crazy. So how much biology do you need to be putting out, and of what type? So answering those kinds of questions, if we've made a compost tea, extracted the organisms from the compost into a liquid form, because it's way easier to apply a liquid than it is to apply that solid material, we're drenching right around the base of all of the plants that we are concerned about, that we want to get going, and making sure that that fungal to bacterial ratio is what it needs to be. So typically that's what we're going to be applying. We will let that do its thing for about a week, and we'll go back and take another sample and look at what's happened in that soil. Has the biology improved? And if we're trying for something that's equal biomass, fungi and bacteria, are both the bacteria and fungi getting higher and higher in value? That's what we want to see. So we're constantly checking. What if you see the place that you were hoping for both bacteria and fungi to grow, and the fungi are just taken off like crazy? Well, that's not good for the plant we're trying to grow. Our plant needs equal biomass. So we'll go back and we'll develop like a compost tea, where we're going to be putting in bacterial foods. So we're getting the bacteria up to where it's going to equal what's going on with the fungi. And so then that gets applied. Well, what if it was the other way around? Well, then we would put in foods that would improve the fungi instead of the bacteria. So we have these tests along the way to make sure everything's going the right direction. If you don't have a microscope and you put things on, you're just crossing your fingers and hoping that Mother Nature is going to be kind to you. And Mother Nature, I think, has a not so wonderful attitude about human beings, because we have not been doing nice things to her work on this planet. And so we've got to fix this and get it back to where it needs to be. And so here you have all of the tools that you need to have. Now, with a compost tea, in general, the reason why we would be making a compost tea is because we've got to up the amount of bacteria or fungi. We also, when we're looking at the above ground part of the plant, the form of putting the biology back out there is going to be as a compost tea, because we want to look and see what's going on. If everything's going just fine, it probably would put out something that was equal biomass, fungi, and bacteria for any tree that's out there. Well, you do want to pay attention to your soil, because when you apply the tea to the foliage, you're also going to be getting some of the compost tea on the ground. So, you've got to be looking at what's going on in the ground. You've got to be looking at what's happening in the foliage, so that you determine what kind of tea are you going to be making? What kinds of foods are you going to be adding into that system? So I mostly only use compost teas if I've got disease-causing problems in the foliage. And then it's strictly a foliar spray. I'm not drenching it on the soil at all. And so we typically get rid of those diseases very rapidly. If you can get out at the beginning of the growing season, you know that there's a particular disease that this orchard or these plants are very likely to have problems. They have, the growers are saying, every year we've been applying these toxic chemicals, and the toxic chemicals just aren't doing the job anymore. What are we supposed to do? Well, you come along and we'll put the compost tea out there. And it does a very good job on dealing with every disease organisms. There's several recent papers in the scientific literature showing that if they put a good compost tea out, that they can deal with fusarium. No problem there. When we were dealing with different, like Dutch elm disease, no problem there. We've got that one figured out. So in some cases, we may have to go into the plantation or into the agricultural field and figure out how to get rid of a disease by applying in the foliage. And most of the time we get it figured out after, just a couple weeks, what we need to do to give constant protection to the plant. And remember that it's not just the organisms you're putting out, it's the fact that you're getting nutrient cycling going again in the root system. You're making certain that that plant has all the nutrients it needs to express the disease protection, to express that resistance to diseases and pests and problem organisms. So it's a whole system working together. And so hopefully you can see why it depends kind of answer.
Yeah, it is a depends kind of answer, and I want to focus on one thing you said, because perhaps I misunderstood. I believe I heard you say that you really only use compost tea if there is an imbalance in the plant, and then if you do use it, you use it as a foliar and not as a root drench. And if I heard you correctly, my question is this: if it's important for us that the plant has the nutrition it needs to remain robust and have an active rhizosphere, so everybody's communicating and trading, and the plant's getting what it needs, if I'm not adding more nutrition and active biology via a compost tea, is the nutrition that you're referring to simply amendments that you have added in advance before the life cycle of the plant?
Well, I was trying to go through the succession of treatments that we usually do in trying to deal with these
I see.
large
That it was
number of
only in that
things.
one case that you wouldn't use a root drench, like you would use it in other cases.
So yeah, when you first go out and take a look at what's in the soil, and you go, oh my gosh, the only thing I find here are bacteria, and they are really not very good bacteria, because that's all that can grow with the toxic chemicals and the inorganic salts and all this tillage. It's the only thing that's surviving. And so our first applications are going to be compost. If you don't have enough organic matter in your soil to grow your microorganisms, and that cutoff is 3%. So one of the biggest things we'll have to do when we've got those kinds of problems is get out there with more organic matter. Well, guess what is in your compost? It's organic matter and organisms, so get it out there. So we'll come back 2 weeks later, and we may go in furrow at that point where we're putting the compost tea down in furrow. Well, we want to make certain that we've got the balance right. So before, here we are, we've put the compost down if we need to, and a week or 2 weeks later, we'll come back and take another look at the biology and make sure it's getting going in the right direction. And then that determines for us what's still missing. And so what do we have to, what kind of compost are we going to use? We're going to be extracting these organisms to put into the soil as a drench going along the row. And we may have to repeat that once or twice before we can get the balance of the microorganisms back up to what it needs to be. And then we're going to really turn our attention to what are the diseases that the client has shown are problems. And so now we're going to determine the compost tea that we're likely to have to apply because of, is it there's too many diseases for me to mention, but based on this disease, we're going to make a compost tea that will very strongly suppress those diseases that are strictly foliar. If it's a root disease, we would probably go back to drenching the soil, or maybe if it's a really specific part of the tree that is showing disease symptoms, and conifers are much more likely to behave in that fashion, we'll inject the compost extract into the soil around that infected root and kind of hope that takes care of the disease in that root. If it doesn't, that's going to kill that plant. And when should we take it down, now or try to baby this one very sick tree? Should we take it down? Your client is the person who's going to make that call.
I understand. Thanks for breaking that out a bit more. It's interesting how any conversation about, if for somebody who's taking their soils seriously and thinking about varieties of compost tea, it always comes back to microscope skills. It really does. It's like, for a decade we were trying to encourage, cannabis growers to get soil tests, right? Even though they were afraid to send their soil in, and because people were generally, hiding and they didn't want to send in soil tests. Eventually it got safe enough to send in soil tests and such. And so, people are pretty well established that on the importance of a soil test, but right on those heels is basic microscope skills so that you can understand what's going on in your soil and your compost.
Mm-hmm. Yeah. And it's easier to do the microscope work yourself rather than sending it off to a laboratory where you're not quite sure what kind of methodology they're using to extract the soluble in, the total in, the exchangeable, all of those different things. And, it's people hand me soil chemistry reports, and, it's got like a column of numbers behind, titles like phosphate, sulfate, things like that. And it's like, this is meaningless. You've got to know what extraction agencies they've been using.
What to the really context is for the numbers, yeah.
Yep. And so, it's really easy to find that information that's important in what do you have to do to get this plant back into a really healthy condition. A lot of times I find the chemical analysis isn't much help. Mm-hmm. And we're working on trying to really figure that out for people so that there'll be a publication coming along that really helps them integrate what's going on with the nutrients from what the biology is doing, as well as having some of the soluble and total nutrient values in the system, help people really figure out what they're doing.
Excellent. Well, we'll look forward to that report. This next question, I think, is a lot simpler than the last couple. It's really common towards the end of a bloom cycle in cannabis for growers to stop water before harvest day. And my mentor did that, and he said, "Well, it's like a tomato plant. We're letting it know it's at the end of its season, and we want to decrease the total moisture volume in the plant so it's a little easier to dry." And I'm like, But in my thoughts, it's always been I would want to be watering my soil biology, all the way through harvest, because without water, I'm going to start losing my stable, balanced microbe life as they start going to sleep. And then that really tells the plant that it's the end of the season, and that, perhaps it's time for molds to take over to recycle the plant. So I want to keep my microbiology like strong and moistured right up to harvest day. But, I certainly am willing to be inaccurate. So what are your thoughts about this common practice to stopping watering plants in containers like a week before harvest?
I don't think it's really going to do the microorganisms in your soil any harm. You're getting them ready for, the harvest period being gone. So these organisms have been, of course, building aggregate structure in the soil around the roots to hold on to water. And so if anything, what's happening is you're getting the plant to go deeper, put those roots down deeper into the soil to grab the water that it needs. So the plant has mechanisms for upping the amount of water that it'll take out of the soil around its root system. And so I'm not sure how much good it really, for a week, is probably not enough to affect the growth of that plant in any way. So, in really dry, arid areas, maybe so. And so it would be interesting to look at that. What goes on with the biology around the root system as you're letting this drying process happen. You're not going to lose any species. They're just going to go dormant. And especially with water, they've got a fair amount of time to respond to the fact that the water really is drying out and it really is time to go get into dormant form. So when you come through and you harvest, you have less damage from the harvest because the organisms are already going sound asleep. It doesn't really ring my bells at all to get worried about that.
So let's talk about something specifically for the indoor cultivators for a moment, Elaine. Many indoor cultivators try to mimic outdoor regenerative techniques in their gardens because perhaps they don't have access to outdoor space, or maybe they live somewhere where the weather is just not going to play ball. And so they want to grow indoors, but they don't want to go the whole, the two-part salts game, because they want to be, using a healthier cannabis themselves. And so, perhaps they're still in pots, but, it's becoming very common to use 4x4 or 4x8 indoor beds. But being indoors, there's a clear limit to how much soil food web biomimicry can take place, because there's so much of nature that you're not participating in and that you just can't mimic indoors in a tent. For indoor folks, how should we think about that natural limit to how much biomimicry we can do, and best adapt our indoor gardens in attempt to, make them as true as possible to the soil food web?
The biggest problem, I think, is going to be that the roots should be growing down and not out to the sides. And I suppose if you had a situation where that's the only you don't have some place where you can hang the baskets with the plants growing in it up at 6 or 8 feet high, so the root systems can go down into a trench that you would dig in the floor.
That's a novel thing to picture.
Take the boards out between your ground floor and the basement. If you could have the above ground part up in a bubble window, and then the pot with the roots growing down into your basement, you might be able to be more typical of what we want to have occurring out in the field. But what if your field isn't actually doing that? Your field is compacted at some depth, and the roots will only grow down to that depth. They will tend to go sideways then and be fighting with the next plants over because they're all not getting the nutrients or the water that they need. So, what is it that you're trying to mimic? Your not so healthy plants that are outside hitting a compaction layer, or you're going to be building structure in that compaction layer. So over the years, you're going to be able to get the root systems of your plants down the 12, 15 feet that we're hoping for. And then you would have to biomimic it inside your house if you brought those pots in.
So it sounds like, since we, even though I really love the idea of sketching out this hanging pots and having it go through a tube to a trough, it sounds like really folks who want to biomimic soil food web, their best things to focus will be on just ensuring that they have got the most complex soil and rhizosphere as possible, by supporting the residents that are already there, and then continuing to inoculate with IMOs and such things, and just focus on the biology of the soil and call that good enough.
Mm-hmm. Mm-hmm. Yeah. Using the extracts, the compost, the teas as needed to try to keep the food web balanced, because one of the things you'll discover is what is the balance of bacteria and fungi for this particular cultivar of cannabis. Which one did you buy, and how much difference is there going to be between this first species versus a second subspecies, whatever? Mm-hmm. That's going to be fun to find out about as well.
So I've just got two questions left for you, and before we go to the final one, which is kind of a delightful philosophical position for us to end the show with, I'd really love you to just give us your elevator pitch about the Soil Food Web School that you started, because so many of us have been accessing your education and message and insights through books and papers and YouTube presentations for these years, but now you've kind of taken all of that and gone pro and made it a system so that somebody can work through the entire range of soil food web ideas, and then get a certificate in the end as well. So, would you just tell us a little bit about that before we wrap up? What
we saw was that people learning the techniques and then going back home and applying them, it's hard for them to do the research kinds of things. We didn't go through that of how to figure things out if it's not exactly the way we were talking about it in the classes. So we realized we needed to start getting our students understanding that every time we say it depends, that means they're gonna have to do a little bit of researching. I like the little containers where we can put in, 6 cups of our woody mix, 3 cups of our green plant material, and then 1 cup of our high nitrogen material. And you mix that all up and make certain that you're watering it so it's got a nice amount of moisture in it. Treat it just like you would your larger compost piles inside the bird cages. And watch the temperature. Is that really high nitrogen that you put in? Is there a problem where you're not seeing any bacterial growth? And you can design your compost system better, but you're doing some testing where you're trying different materials as high nitrogen. Which is the best high nitrogen that I've got? Which is the best woody substrate? Does it matter if I let that woody substrate get completely involved in a bunch of different fungi, and I use that as compared to something that was just ground up, 2 or 3 months ago or something like that. And so you test for yourself, and we're teaching our students that way to deal with questions that you might have, and figure it out for yourself. Now, we'd like to have you all send back in what you discover, so we can just keep enlarging the table about where in the world are you and what is the best source of high nitrogen, the best sources of woody materials, and so on and so forth. Lots of examples that I could give, but I'll keep going.
It sounds like the main gist or intent, I guess, is probably a better word for the Soil Food Web School is so we've studied these ideas of the Soil Food Web, wrote to memorize them, and what the school does is it gives you the skills to do the research so that you can do the processes that you need in order to be able to work with soil, not just like you read it in a textbook, but that you actually have ownership over the techniques and the ideas.
Yep.
Right.
Because we know that every bit of a biome is not going to be behaving the same way, especially if you understand succession, which I just barely started going through, which, when you look at a watershed and you look at the fact that up there at the top of the mountain is mostly conifer forest, and then you've got deciduous forest, and then you've got the shrubs and bushes, and this is succession. You're looking at succession. So where is your land, or where is your client's land? Is it down here in the riparian zone? Is it a weedy area that gets disturbed all the time by wild and crazy things? Going up the slope a little bit into shrubbery and really highly productive grasslands. You have to have that microscope to be answering most of these questions about what's missing, so you can pretty easily start to build a good library about here's what you do when, fill in the blank. And if we can have that for the school, so you see what we're doing is what are the things that will make it easier and easier for students to be successful out in the real world.
Yeah, it sounds like it's a setup for what to do when the answer is, it depends.
Yeah.
So let's follow with this one. So Dr. Elaine Ingham, you've been an educator and an activist, actually, for soil health for decades. And it's certainly true that regenerative growing techniques have, increased in popularity, and the generations behind us are even more interested than us. But also, the fertilizer lobbyists also still have a strong hold. And what advice or insight would you share with those who will carry the torch forward in this fight that sometimes almost seems overwhelming?
Well, it seemed overwhelming to convince the world that soil is alive 45 years ago. And yet we've done that. It's amazing. Once we got over kind of the threshold of people accepting that, it didn't matter what the chemical companies were talking about. It didn't matter that our politicians are in the pocket of those people. When the general public decides, it goes that way. And so we've got to make this as understandable for the average person that they get it and they demand that their food is grown this way. So, we're going to get all of our nutrients from plants that are cycling nutrients and building protection, and that transfers to us. The microorganisms on the outside of all of the food that we eat should be what Mother Nature put there, and not what we put there by spraying pesticides or spraying, for whatever it is we're going to go out there and try to kill. You don't ever kill if you don't have to. I guess there's a few exceptions like human pathogens. Yes, we do always have to kill them. But it's going to be using a system that is not toxic chemicals that spread everywhere, that leach from all of our ecosystem, from all of our agricultural systems into the water, and destroys water quality of everything downstream. So we've got to get the reasons for dealing with landfills that are just oozing horrible combinations of toxic chemicals into the rivers and lakes and streams. And how are humans supposed to survive if those are the kinds of systems that we're living in?
Yeah. Thank you, Elaine. So this brings us to our end. Dr. Elaine Ingham, thank you so much for sharing your time and your expertise to join me today here on Shaping Fire. But even more so, thank you for your long career of research and sharing it, and giving a damn and sharing that too. It was absolutely I've enjoyed hearing you talk before, but it's been an absolute joy to have the opportunity to actually interact with you. Thank you so much.
Well, thank you. Some great questions, and you led me through them in a really thoughtful and useful way. So I hope we can do this again.
Wonderful.
Next year.
Thank you. So, dear listener, if you would like to hear more from Dr. Elaine Ingham, you're in luck, because she is a guest that there's a whole bunch online. So I recommend you start these three places. The first and foremost is soilfoodweb.com. That is Dr. Elaine's website. It's the home of the school. There's all sorts of resources, and it's a great place to start. The second place, especially if you are interested in learning some techniques as you go, is the Instagram for the school as well. And that's Soil Food Web School on Instagram. And that there are like kind of, institutional posts about what's going on at the school, but there's also a whole bunch of technique in there as well. And, it's a profile that I enjoy following. And then finally, probably the best place to go is YouTube. If you like listening to your education like this, there's a whole bunch of stuff that Elaine has done online. And then, of course, Dr. Elaine is, a very published scientist. And so if you also like to read your education, you can find, many scientific papers and her books, with a simple search online. You can find more episodes of the Shaping Fire podcast and subscribe to the show at shapingfire.com and wherever you get your podcasts. If you enjoyed the show, we'd really appreciate it if you would leave a positive review of the podcast wherever you download. Your review will help others find the show so they can enjoy it too. On the Shaping Fire website, you can also subscribe to the newsletter for insights into the latest cannabis news, exclusive videos, and giveaways. On the Shaping Fire website, you will also find transcripts of today's podcast as well. Be sure to follow on Instagram for all original content not found on the podcast. That's at Shaping Fire and at Shango Los on Instagram. Be sure to check out the Shaping Fire YouTube channel for exclusive interviews, farm tours, and cannabis lectures. Does your company want to reach our national audience of cannabis enthusiasts? Email hotspot@shapingfire.com to find out how. Thanks for listening to Shaping Fire. I've been your host, Shango Los.